Live from the central coast of California, this is NASA's launch coverage of Sentinel-6, Michael Freilich.
From space, it's just one planet.
Sea level rise is really interesting because the impacts are local, but it's a global problem.
We really need to understand how it's changing. How is it evolving?
Wherever you live on this globe, the oceans will influence you in some form or the other.
We've been measuring the height of the ocean since the beginning of the 90s.
We really need that long duration observation.
And Sentinel-6 is going to allow us to continue that record.
So that we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It really impacts the daily lives of people and their ability to plan for their future.
And that's why humanity has been monitoring global sea level from space with exquisite accuracy for more than 28 years.
A satellite dedicated to uncover
How is it evolving?
Wherever you live on this globe, the oceans will influence you in some form or the other.
We've been measuring the height of the ocean since the beginning of the 90s.
We really need that long duration observation.
And Sentinel-6 is going to allow us to continue that record.
So that we can better predict what is the rate of change, what is it going to look like in a year, 5 years, 10 years from now, and so forth.
It really impacts the daily lives of people and their ability to plan for their future.
And that's why humanity has been monitoring global sea level from space with exquisite accuracy for more than 28 years.
a satellite dedicated to uncovering new knowledge about our rising seas deserves to be named after someone who dedicated his life to understanding our oceans.
Earth system science is bigger than any particular agency. It's bigger than any single nation. It's bigger than any single continent. And I surely hope, because humanity requires it, that we make some significant progress in understanding.
You start to realize the importance of understanding what sea level is doing now, and we can use that understanding to know what sea level might be doing in the future.
Scientists around the world are using this data to help people.
The importance of this project and where it touches is on all walks of life all across the world. Sentinel-6, Michael Freilich, is all about water.
And in just about half an hour, this SpaceX rocket will launch the Sentinel-6 Michael Freilich satellite into space to continue the important work of monitoring changes in our oceans around the world. And so it seems fitting, this satellite will begin its flight over top of the largest ocean in the world, the Pacific. Welcome everyone watching on NASA and SpaceX's platforms. Thank you for joining us here at Vandenberg Air Force Base on the coast of Central California. I'm your host, Daryl Nail, and with me is Marina Jurica with NASA's Jet Propulsion Laboratory. So good to have you here.
Oh, thank you so much, Daryl. I'm so honored and excited to be here. The launch pad right behind us, Sentinel-6 getting ready to launch and giving us another decade of sea level observations. The science return is so critical, and I'm so excited to be here.
Now, you're a meteorologist as well, so you know the value of the data that's going to be coming from this satellite once it gets into space and starts working. But now comes the hard part, which is launching it into space.
I know, and I'm feeling so excited to get this Sea Scout launched and into action. I'm so invested in the incredible data that's going to come from this satellite, the legacy that it follows and continues. And we all live on this Earth here together, so we need to make it a better place for everyone.
Well said. And right now, as far as the rocket's concerned, we are go for launch. We'll get an update from Launch Control in a minute. We'll take a look at the pad, though. The rocket looking beautiful out there on Space Launch Complex 4. Now, coming up in the show, we'll learn more about Michael Freilich and why this satellite was renamed after him before he passed away. We'll also talk live with his son and his daughter after the launch.
The satellite he's named for can do some incredible science. We'll show you how it detects sea level changes down to a single centimeter and how it helps forecasters make better predictions about the strength and the path of life-threatening storms like hurricanes.
And just before launch, we'll talk about the cool secondary mission of the landing of SpaceX's first stage booster right back here on land, just a few hundred feet away from the launch pad.
Then after the launch, join us for a live transatlantic conversation about climate with scientists from NASA and ESA, European Space Agency.
But first, let's introduce you to the team of commentators who will be calling the launch today. NASA's Joshua Santora and launch trajectory analyst Philip Hargrove. Gentlemen.
Hey, thanks so much. It's been an active past few minutes, starting to hear calls of closeout and things. But before we go too far, I want to, Philip, ask you to introduce us to the teams that are on console today. So there are teams of teams really working this launch. Who do we have on board today?
You're absolutely right. So we have our international partners from the European Space Agency, or ESA, and the NASA Jet Propulsion Lab, or JPL, who have science instruments on board the spacecraft that was developed by ESA. SpaceX obviously manufactured and produced the Falcon 9 rocket, and the NASA Launch Services Program, or LSP team, has been working closely with them for the past couple of years to prepare for today. And the United States Space Force Range is responsible for public safety today.
Yes, grateful for everybody's participation. Lots of good comments made this week during briefings and reviews about just the incredible partnership and collaboration here. So I want to tell you about what's coming up through the rest of the count as we proceed towards liftoff here in just 5 minutes now. We should hear a call for RP1 full in just a second. And then we'll be looking for the strongback retract to take place in just a few seconds.
Propellant tanks are pressurizing for strongback retract.
Perfect. So what that's going to look like on your screen is up near the top of that rocket where the fairing is, just beneath the bottom edge of that fairing. You can see that on screen there very well. There's a clamp that's wrapped around the second stage of the Falcon. That clamp will expand, and then that tower, the strongback or transporter erector, will tilt back just a couple degrees in preparation for the final minutes of countdown. It will still be connected.
Retract has started.
There's that call. The retract has started. That strongback provides power, fluids, and communication for the rocket up until the time of liftoff, when it will tilt back even further away from the rocket. So keep your eyes on that. But Philip, wanted to have you tell us about the path for today's flight. The folks along the southern coast of California might get a treat if they're outside looking up to the sky.
Right. I'm definitely happy for the people out there in Southern California because, we get a million launches out here, but, if they can finally see some, especially at JPL, because it's, they're invested in this launch. So Vandenberg is really convenient for these high inclination launches. So Sentinel-6 Michael Freilich has a 66-degree inclination, which means that it's perfect for the Falcon 9 to launch south-southeast, and it's really going to kind of ride along the coast of Central and South America on its way up to that 1,300-kilometer altitude.
Yeah, very good. We just heard there Tim Dunn coming on the nets and giving his official go. So NASA is go for flight here. The last few minutes here, we're going to hear a number of calls with closing out liquid oxygen, or LOX, and then we'll kind of tick down here to the final minutes where we'll hear we're commanded for final pre-launch. We'll have the automated flight termination system will be configured for launch. We'll get a final go from the launch director at around 45 seconds to go on the way to 0 there, right on time for this instantaneous window at 12:17:08 Eastern Time. That's 9:17:08 there on the ground. So, Philip, really fast here as we're waiting for the liftoff. Tell us about the rocket here. You kind of told us about the flight path, but what is this rocket capable of? There's a lot going on here.
Right, there's a lot going on, and we have some beautiful views of this Falcon 9. So you can see it's a two-stage rocket. The first stage, or the booster, goes about 2/3 of the way up, and that actually provides 1.7 million pounds of thrust, which is going to get the vehicle and the spacecraft off of the pad. The second stage, its engine is housed in that black interstage region that's just below the 5-meter fairing, and that's what's going to finally bring the spacecraft up into its orbit. And as we've discussed already, that first stage, once it separates from the second stage, is going to head on back to Vandenberg.
Awesome. So much coming up here. Post liftoff is certainly active as well. About a minute into flight, we'll hear calls for flight through max Q, or maximum aerodynamic pressure, and then we'll about 2.5. strong record track has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. It's densified liquid oxygen mixing with the ambient temperature there, which creates that fog, that steam effect. We'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very, very late into the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3, 2, 1, 0. And liftoff of Sentinel-6, Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal. M1D propulsion is nominal.
Power and telemetry nominal. Vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1 boost back burn has started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an
Both
orange.
vehicles are following nominal trajectories. Burn separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6 Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost back burn, shutdown.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second stage.
Vehicles continue to follow nominal trajectory.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like, we know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of space.
Entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It was incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. I mean, can you tell that we were excited? We were standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burn. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2, and we're going to call that out Here it comes. There it is.
Wow. Oh my goodness.
Coming in at an angle.
Oh my God.
And just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness. I might cry right now.
This is so incredible. Every time I see this, it's just
slowing down so perfectly.
Perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my we heard that.
Oh, that was
And Falcon 9 has landed at LZ4, landing operator
beautiful.
Speed into 11.100 on recovery 2.
I'm a little
The
teary-eyed right
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? That sonic boom is recognizable wherever
and
you are.
Reverberating through the valley here.
I know.
Well, what'd you think, Jesse?
Oh, I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
The crowd that's with us, you can hear them cheering and everything. They're just totally like, you know, in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
So much for having me. This has been amazing. Thank you.
Absolutely.
Thank you. It's correct. I'm just checking my comm loops here, make sure we're hearing everything. We're expecting to hear that call for the second stage, second burn, any second now. So we're kind of in a holding pattern here, just kind of cycling back on the day. We had successful on-time liftoff at 9:17:08 Pacific time. There you see on screen, that's a track.
Nominal payload insertion orbit.
That's a great call. I believe, Philip, help me. I believe that's a call for, like, we've completed the second stage burn, a nominal insertion orbit. That's where that's where we wanted to get to, right?
Exactly. Yes, the first stage did most of the work of getting out of that gravity well to get away from Earth into orbit, and then that second stage, second burn, was really just tweaking to get into that final circular orbit.
Yeah, fantastic. And we're seeing now some great shots from that second stage, and we saw the spacecraft there a second ago. So that track that the rocket has flown, it's tough to see because this is simulating, this image on screen is simulating being in the shadowy part of the Earth right now. So if you look really closely, you can see we're kind of approaching, if not in the Indian Ocean now, we're to the east of Africa. The track, as Philip mentioned earlier, that 66-degree inclination kind of put us around the tip of South America and then around the tip of Africa without actually dipping down to Antarctica. So kind of a fun track to take. We're expecting to have signal acquisition of the spacecraft over around Alaska. So lots to come ahead. But Philip, I want to ask you about your work because this is kind of the bread and butter of your job as a flight analyst. You definitely pride yourself on getting to this point and beyond. So tell us about what you do.
Right. I mean, be careful with that question because we've been talking orbits all day, so don't get me started on it. But when you talk about trajectories in the launch sense, there's really two pieces. There's what happens when you are in orbit, when you're already in space, and then there's the unique question of how do you get from the launch pad into orbit. So at LSP, at the Launch Services Program, we really speak both languages. So we want to be able to take the work that the spacecraft team does to determine what all of their needs are in terms of where they need to be and when they need to be there, and we help translate that efficiently to the launch vehicle, who has their own process of designing the actual trajectory to get from the launch pad into orbit. So we support that process however we can.
Yeah, and that's, as you kind of alluded there, that's really the bread and butter of the broader LSP picture. Working with a spacecraft customer to acquire the vehicle. We heard Tim Dunn speak about that yesterday, just the acquisition of the vehicle and the service to get into orbit as you need to be. So what's kind of that picture like for LSP? What's the process at large?
Right, so we really just want to support those spacecraft and do whatever needs to be done to make sure that they are going to be placed into the specific orbit safely. So there's a lot of things that LSP does to just keep a grasp on the evolving launch vehicle markets. Being able to know exactly what the spacecraft is or what the launch vehicle is going to do before it's actually purchased, so we can advise them so they can do their planning years in advance before they're even purchasing their vehicle. So we really just want to sort of be that interface for NASA.
Yeah, and I want to check in for a second to say we just heard a call of acquisition for Diego Garcia. That's not the spacecraft acquisition. That's a stage 2 acquisition. So we'll be looking for this spacecraft acquisition over Alaska as we get to the Alaska general geography. And we're hoping to, ahead in our show, bring you the spacecraft separation video live, or close to live. It'll be a few seconds delayed. It takes a few seconds to get that signal back from the other side of the Earth where we already are. I do want to go ahead and bring in now another flight analyst, Callie Burke, who's also with Launch Services Program. Callie, thanks for joining us today.
Yeah, I'm here in my own little booth in the Mission Director Center.
Yeah, I appreciate you. You're kind of isolated there in our booth over there. Glad to have you. And I know you wanted to talk a little bit about today about kind of the choosing of the orbit we're in. Obviously, we had a good call out for nominal insertion burn. So where are we and why did we choose this specific orbit?
So as a Launch Services Program, we go where the spacecraft asked us. And so we're going to, if this was the equator at 0 degrees, we're going to a 66-degree inclination. So it's a high inclination orbit. And so it's doing the same one that Jason 3 is in decades of continuous data. And so that going up that high means we go up, as high as Alaska and Sweden, but then sweep down below South America. And so it's a nearly circular orbit. And so it's around, around the Earth, it's about 800 miles above the Earth, which is about 1,300 kilometers.
And why such a long coast phase? I know that for those that are familiar with rocketry, they kind of are accustomed to science missions and robotic explorers having a coast phase that can be fairly lengthy. But why this 45-minute coast before the second burn?
So with the rocket, we bring all the gas with us. There's not gas stations in the way. So we want to try and use as little as possible. And so just the way that it works is that, we start
Callie, I want to jump in there for
we
a
fly
second.
up in the early parts to a
We're looking at the spacecraft separation right now. I want to let you finish, but we're getting that live, and I wanted to call that out for you. So there goes Sentinel-6. That is a beautiful sight. Watching it drift off there. Again, we are kind of shaded by the Earth, so we're not in direct sunlight at this time. So that's why it's as dark as it is. If the sun were on this side of the Earth, we'd see a little bit more of that, but that's going to kind of just drift off, and that's completely normal and expected. So, Callie, I do want to let you finish. Sorry for jumping in there.
No, yeah, that's the part, it's the exciting part when the rocket's done its job. So what we did was we got to a park orbit coast with the boost and the first burn. And so with that, we still had a perigee, so the point we're closest to the Earth, just above 160 miles. And so we were near that. And then we coast and just let physics do its job, where we go out to the furthest part, 800 miles. And then at that point, we just have to do a short burn, just every 10 seconds, a little bit more. And then, we circulate the orbit. So we are just using a little bit of fuel at that point. So.
Awesome. Hey, last question for you really quickly. I wanted to ask about the question of how far would we be behind Jason 3? Because obviously we're trying to be in that exact same orbit like you mentioned, but how far away are we?
So what we're doing, so we have our launch time so that we're in the same orbit plane as Jason 3. That's why we had just that 1 second to launch. And then we're going to be just minutes behind. And they're zooming around at 3.5 miles per second. And so if they get, if Sentinel-3 gets as close as just 30 seconds behind Jason 3, that's still 135 miles behind it in the orbit.
Yeah, I think I just heard you say 3.5, but I know we talked that numbers that we deal with a lot of numbers, and I wanted to make sure was it 3.5 or 4.5?
It is 4.5.
Okay,
you are correct.
No worries. Again, we deal with lots of numbers. Callie, I appreciate you being here with us. Thanks so much, and appreciate your hard work for LSP and getting our spacecraft customers where they need to be.
Yeah, go Sentinel-6, Michael Freilich.
Yes, awesome. Thank you so much. Yeah, that speed of 4.5 meters per second. Or miles per second, thank you. It actually means that we're traveling at a speed that would put you from ESA's headquarters in Paris, France, to the launch site at Vandenberg in about 20 minutes. So pretty speedy there. There are still a few milestones ahead. We hope you'll stay with us. We're going to send it back over to Daryl, but just preview for you quickly. Solar array deploy is ahead, and then that signal acquisition we mentioned. Daryl, back to you.
In our launch operations, the unfolding of the satellite solar panels. Joshua?
Before we do that, we want to recap the launch, just a quick moment to share with everybody and let them know exactly what happened about 45 minutes ago. It was a beautiful launch here on the coast of Central California. The Sentinel-6 Michael Freilich satellite, which is sitting on top of the rocket, was ready to go. We had clear skies. There was an ignition of the rocket right at 9:17 p.m. Pacific time. I'm sorry, a.m. Pacific time and 12:17 p.m. Eastern time. And there you see the launch of the Sentinel-6 Michael Freilich space satellite going up on the Falcon 9 rocket. And it's a beautiful sight, looking down the barrel, both of the booster as well as the skies above. It just climbed and climbed, racing up to the middle of the blue sky and performed beautifully. No problems with launch. The 9 Merlin D engines belting out their 1.7 million pounds of thrust on their way into space. The rocket just performed perfectly, and there you see a shot from up high and the coast of California. Vandenberg here, of course, a launch site that allows for a certain trajectory that allows Earth science to do a lot of missions here. And then we had the landing, which was really neat. For all of the guests who were here, Michael Freilich's family, watching as that booster touched down just perfectly, nailing the landing. It was quite a sight to behold about 8.5 minutes after launch. The first stage booster now available for reuse. So now we want to check in with Joshua Santora and Philip Hargrove for an update on the second stage.
Well, that's right. We are now going to be having a very big moment as the unfolding of the satellite solar panels moves in. And Joshua, it is an exciting time. Everything's coming into place.
Liftoff of the Falcon 9. Godspeed, Sentinel-6 in memory of Michael Freilich.
and our European Welcome back to Vandenberg Air Force Base in Central California. My name is Daryl Nail. I'm joined with Marina Jurica from JPL. Thanks for joining us. We have an update for you, some good news. We managed to get an acquisition of signal from the Sentinel-6 Michael Freilich satellite, and as well as confirm the deployment of the solar array.
That's right. So the solar arrays, the solar panels have now been deployed, and what's incredible is we got the signal of acquisition. In layman's terms, it basically just means that the satellite is healthy, it's in the right orbit that it's supposed to be in, and we are ready to rock and roll to get that science getting to us as soon as possible.
And that's an exciting moment for us here at NASA, as well as ESA and our European partners. It all started at 9:17 in the morning Pacific time from right here at the Vandenberg Air Force Base Launch Complex 4. SpaceX launched their Falcon 9 rocket from that launch complex around 12:17 p.m. Eastern time, and it was an incredibly beautiful launch. Rare conditions here for a launch. A lot of the folks around here say we had clear skies, beautiful as this rocket lifted the satellite off the launch pad, Marina.
Oh, it was incredible. It was crystal clear, and usually we have fog all across this area, a really thick marine layer, but it was crystal clear blue skies, and then we saw the booster land back next to us. That was just unbelievable. We heard that sonic boom. It was so powerful.
And in fact, it came down right in eye level, right back at the place where it launched off the pad. And so it was just fascinating and a wonderful thing to watch. But the mission then later continued, and you can see there the separation of the satellite from the second stage booster. That confirmed beautiful video there from an onboard camera on board SpaceX's second stage, watching that Sentinel-6 Michael Freilich satellite go off into space, and Michael Freilich's family here to enjoy it. We want to toss it now back to the Kennedy Space Center, where Joshua Santora and Philip Hargrove are there and documented and heard the acquisition of signal. Gentlemen.
Yeah, thanks, Daryl. Obviously, all smiles here. That's what we want to hear. We got a great set of calls there, and we heard a number of times calls come out repeatedly saying, hey, we can confirm we definitely got the solar array deploy, which was something I know that we had left you last time not sure of, so glad that happened.
Right, and it was really great to hear the excitement from the spacecraft team over the nets, so they're happy that they can talk to their satellite, and yeah, Sentinel-6 Michael Freilich is on its way.
Yeah, it's funny, typically during a launch countdown and even post liftoff, it's very quiet in control rooms. It's very focused. You want to make sure everybody can hear what they need to hear, but we heard calls coming in and just people just explosively cheering in the background. So excited for those teams. A huge congratulations to all the teams involved today. Obviously, ESA, JPL, LSP, the Space Force, and SpaceX. So, Philip, it has been a pleasure to have you alongside me. Appreciate your insight and expertise on the topic of rocketry.
Thank you so much. This was an awesome experience, so I'm glad I got to share it with you.
Fantastic. And from here at the Kennedy Space Center, doing commentary, there's a lot of missions between now and then, but we hope you'll be back in about 5 years when we get to see the sister of Sentinel-6 Michael Freilich fly, Sentinel-6 B, the twin sister that will fly in 5 years to continue that service of ocean observation. That's going to do it for us. Daryl, Marina, back to you.
All right, Joshua and Philip, great job, guys. We appreciate it. And like you said, in 5 years, we'll have that second satellite. That really helps to that continuity of data. Right?
That's right, the consistency and the continuity, adding that full 10-year block. And that's what makes it unusual to other Earth science missions, is that the satellite is already built and it's stored and it's ready to rock. And in 5 years, we'll get that one up and it'll be 10 years, a full decade of this critical information, because we know sea level rise is happening. We know it's accelerating, and this is just going to give us another 10 years, which will be 40 years of consistency and continuity in this data.
And what a place to watch all of this, right? We had beautiful weather. We're here on the central coast of California. Many thanks to the 30th Space Wing for helping us out and making this possible. They really did a great job.
It was so beautiful. I've been here so many times. This whole valley is usually covered in fog. We were here just a couple of days ago and everything was foggy because we get this marine layer that just pushes right into the valley. But today, everyone was in place. The weather was in place for us, the rocket was in place, the booster was in place, and now the science is in place.
That's wonderful. And how'd you like that landing?
Oh, that was incredible. I've only seen it one other time, and that was the double landing, which was pretty amazing. But this was just as amazing in my home state, in my hometown, with my family watching, and most importantly, Michael Freilich's family watching. What a moving moment when we got to speak to his children. He was an incredible, incredible advocate for Earth science missions, and especially for altimetry data and sea level rise, and it was so heartwarming to see them here.
Yeah.
It was just wonderful.
There's another star in the sky.
Yes.
It's got Michael Freilich's name on it.
You've got it, Daryl.
All right. Well, we thank you for joining us. That's our coverage of Sentinel-6 Michael Freilich, the launch of that satellite on a Falcon 9 rocket by SpaceX. We appreciate you being here. For everyone here at NASA, thank you for watching, and remember to keep looking up.